Hello, everyone. Welcome to today's LinkedIn Live event, where we will be unpacking a CVE that was released yesterday. It's the HTTP2 Rapid Reset CVE. It's obviously gaining a lot of popularity, and today we're planning on discussing with you the overall impact, the importance, and the challenges of asset inventory as we see more and more of these critical CVEs surfacing at a pace that we've never seen before. My name is Nabil Hannan. I am the field CISO at NetSPI. And today I'm joined by a member of our attack surface management team, Isaac. Isaac, do you want to share a little bit more about yourself with everyone before we get started?
Sure, yeah. As Nabil said, I'm Isaac Clayton, and I am a security research engineer on the attack surface management team. I'm responsible for basically building in kind of all of the automation, all the scanning that happens on our attack surface management platform. And so to do that, I kind of look out at the threat landscape. I see the stuff that the good guys are doing, stuff the bad guys are doing. I try to figure out what of that would add value to the product, and then build ways to incorporate that into our scanners. Yeah, does that give you what you want, Nabil?
Yeah, I mean, you're being modest. I'm sure there's a lot more that people need to get to know about you. But for today, let's dive right in. Isaac, tell us what's happening with this rapid reset CVE, and in particular, maybe start with an overview of the current situation that we're seeing out there.
Sure, yeah. So I want to start by saying, like, I am drawing from a number of really good resources out there in the comments I'm going to make here. I absolutely recommend everybody go check out the Cloudflare blog, for a kind of real deep dive into the vulnerability itself, as well as some of the stuff that they're doing, like to protect their customers. It's really cool stuff. Similarly, Google's published a few blogs to that effect. But in general, what's happening is we have a vulnerability that dropped yesterday that describes kind of a flaw in the protocol of HTTP2 that enables or could enable an attacker to cause what's called a denial of service attack against a vulnerable system. So a brief kind of reminder for everybody what a denial of service attack is. It's an attack that, as the name suggests, denies service to the intended users of a system or a piece of infrastructure. So that can be quite bad, and we can talk about some of those things here in a minute. Just to kind of give you a little bit more detail on the actual vulnerability itself. What it stems from is when we look at the kind of last version of HTTP, it had some inefficiencies that were not huge problems in the kind of Web 1, Web 2.0 era. But as we kind of come into this new era of massively kind of scaled up compute, we're seeing those inefficiencies create problems for systems at scale. So when HTTP2 came out, it introduced kind of some really important features that reduced overhead both for the client and the server. And to do that, there are a few features that got kind of tacked in there. And one of these features, which is the ability to do a reset stream, is what's implicated in this vulnerability. So I'll pause there and I think we can discuss that more in detail as we go on.
Yeah, so maybe you can elaborate a little bit more here, Isaac, right? Why is this reset stream, which seems like a very normal behavior or functionality that should be expected in the protocol, what is it that's unique about the anatomy of what was discovered and how this was architected that's causing the actual denial of service? Are you able to maybe elaborate a little bit on that concept?
Yeah, sure. So, I mean, I think our audience is probably familiar with some of these technologies and protocols we're talking about here. But again, as a reminder, the protocol that underpins the entire web is HTTP, and it has been for forever. So, one of the features of HTTP in its original form was it required a lot of overhead in the form of like multiple TCP connections to do kind of requests and responses between client and server. What happens in HTTP2 is it's like a single connection with multiple streams that enable kind of a much more efficient communication between client and server, because it's not having to constantly renegotiate that TCP connection to handle multiple requests. So when you think about that kind of architecturally, you think about what would you need in order to make that work? Well, you would probably want, if you're going to have it be efficient, you would want to have the ability to, have a client say and a server say, hey, stop doing what you're doing. This stream is no longer good. Let's move on to something else. Let's not waste the bandwidth. Let's not, waste the compute on processing whatever we're processing. And so that's what the reset stream is at a really high level. It's the ability for both the client and the server to tell the other one, hey, we're done with this stream. Let's close it. The problem comes in, and in my opinion, there's probably more nuanced views of it out there, but in my opinion, the problem there is that both the client and the server can send this unilaterally, meaning there's no dependence on the other to be able to send this. And so what this results in is a client saying, hey, I'm done with the stream. But when the client says that, the server still has some work to do, right? Like the server still has to say, okay, I'm going to clean up the stream, and I'm going to close it out. And so in onesies and twosies, that's not a big issue. Even in probably hundreds, that's not a big issue. But where it does become an issue is when a client maliciously sends opens many streams, and then resets or closes those streams and continues that process over and over again. I'd say this is in contrast to like HTTP denial of service attacks of the past, where you might have a bunch of different connections initiated. This, you have a single connection initiated, but you have many streams being initiated and then closed and initiated and closed, and the server has to kind of process that closing of the streams, and that which results in the lockup of the system and the denial of service.
So Isaac, if I understand this correctly, this is basically having an exponential impact with a very minimal number of requests, because you're able to throttle and get the system to basically get overloaded with millions and millions of requests per second without needing millions and millions of computers to send those requests at a time, just because of the nature of it, right? So that's why we're seeing such a big impact, I think, in layman's terms, as I think about it. And this brings me to the other piece I want to dive in with you, which is the far-reaching impact of an issue like this. And needless to say, I think the statistic I read was a little over a third of the internet is still using the HTTP2 protocol. So this has obviously got a very far-reaching impact. But help me maybe understand, who should really care about this? And from your perspective, in the technical sense, what is the true impact of exploitability of a CVE of this nature?
Yeah, I mean, I think I should preface this by acknowledging my bias. I am a security research engineer, so I'm probably going to be a little more concerned about this than your average Joe. But I think, frankly, I mean, you think about what the internet is. Let's step back and let's look at what that actually is. It's not just this place for sharing cat pictures or social media or things like that. There are a whole lot of kind of critical infrastructure that's connected to the internet. And one thing we've seen over the last decade or two has been the explosion kind of complexity of the systems we're building. So in the olden days, it might have been Nabil with a web server in his house, and that was what the internet was made up of. But now we're talking about really complex assortments and architectures that are really fragile, actually. And behind those things, those systems are all serving things that we actually care about quite a lot. Whether that's government systems or infrastructure, like physical infrastructure systems. The internet is enabling a whole lot of things. So when we talk about a vulnerability that impacts a third of the internet potentially, we're talking about a vulnerability that might make unavailable some really important pieces of critical infrastructure. So at the highest level, I think the impact is potentially quite large. Now, that being said, I think that one of the saving graces for us here is that one of the other trends we've seen over the last couple of decades has been a migration away from kind of on-prem hosted servers, not entirely, but a lot of that stuff has moved into the cloud. And so that means that, like, with that level of centralization, the good folks over there at Amazon and GCP and the Microsoft, they have the ability to introduce mitigations into their systems that protect the people who are hosting those servers on their systems in a way that you probably couldn't if you were hosting all of that yourself. So I think that is it a big deal? Absolutely. We have basically a third of the internet running a protocol that, at least in some implementations, is potentially going to shut down those servers. Is it able to be mitigated? I think yes. But the challenge in front of us here is how do we identify what systems are going to be the ones that are vulnerable, that need our attention, and what ones are there mitigations in place for? And so I think that's kind of where the problem comes in, and the kind of work for people like me and and the ASM team at NetSPI.
As I hear about this from you, Isaac, it reminds me of the concept that I read about in the software, for one of the first software security books by Gary McGraw, where he refers to this thing as the Trinity of Trouble. And that's connectivity, complexity, and reusability. So when we look at something like this and try to figure out, well, how did it get so large from an impact perspective? You know, connectivity is literally at the core of what the internet is, right? So we're connecting things with each other. And in order to be successful in making those connections, we need a communication protocol that everybody understands so that we don't have to create different protocols for connections with different types of devices, networks, applications, etc. Then I think about the complexity factor, right? You hit it on the head there, right? Where, you know, before, maybe 15 years ago, people were hosting their web application, as an example, on a machine at home, and you would host it yourself. Then we went into the hosted providers, where you would get hosting that was, you know, we didn't call it cloud then, we called it hosting, and now an extension of it has become the cloud. So we're getting more and more complex as we make more and more connections, which introduces more opportunities for something to go wrong, which is what we're seeing here. And the other piece is reusability. You know, I think about the overall software development concept of like object-oriented programming, and the whole goal of that is to build blocks of feature, functionality, or software that can be easily reused everywhere. And as we learn more and more that software is being stitched together from various sources, various open source libraries and projects and frameworks, and even closed source components, you know, you have protocols that are now getting wide adoption, such as HTTP2. And that's why when you have a CVE like this, the impact ends up being just so much more far reaching than you originally expected to be. And I feel like it takes me back to the concept I read about that Trinity of Trouble. And it's another way to kind of reflect on it, that this applies here just like everything else, where you're getting in trouble because of those factors of connectivity, complexity, and reusability. And when I think about it from a more business impact, you know, we are getting more and more dependent on multiple systems that may be built and hosted by separate groups, organizations, or people to be available in order for you to leverage them and have them be available. So when you have a denial of service scenario that you can conduct against one system that might be a central feature that supports other systems. And the example I think of immediately is around authentication. You know, a lot of people leverage single sign-on and leverage maybe their social media accounts, such as Facebook, Google, Apple, Amazon, to log into various different software, so they don't have to go create unique accounts everywhere, create unique passwords everywhere. When they leverage something like that, if you have a vulnerability like this that can impact one of those authentication services that's centrally managed by one company, the impact is even more far reaching, because the DDoS attack may not be against all these other applications. It may be against the central authentication system, but these other applications become completely unusable and inaccessible to the regular users, which is a big problem because there are organizations and businesses that heavily rely on services for authentication from different providers in order to conduct their business. And all of a sudden they have a situation where their customers cannot essentially spend money with them. That's ultimately the goal of the business, is to figure out how to make more money, and their users aren't able to use the systems, which is why there's this particular challenge in this particular situation. So, you know, the thing I want to learn next from you, Isaac, is from your perspective, are there specific immediate next steps that you think an organization can take to mitigate their exposure and risk to this particular vulnerability?
Yeah, sure. So the answer is yes, I think. I think it depends a lot on kind of what your infrastructure looks like, and hopefully this is something that all organizations know. And if not, you know, we should talk. I think so. Hopefully, people have a pretty solid inventory of what's out there, what their organization's infrastructure looks like. Some people are going to have stuff in the cloud. I already kind of touched on that. I think a lot of those people who have infrastructure hosted in the cloud may or may not, depending on where it is in the actual implementation, they may or may not be protected. I think that the real kind of area for concern for organizations is going to be in infrastructure that's hosted kind of on-prem or that they maintain and manage themselves. So if you're running, again, Nabil, in your office somewhere or your house, if you've got a web server running Apache or something, an unpatched version, I would highly recommend you go out and install patches if they're available yet, which I think they are. But if not, as soon as they are, I recommend you do that. Now there are some more kind of more, for lack of a better word, fancy kind of mitigations that are outlined, for example, in the Cloudflare and Google blogs, of ways that you can kind of intelligently do that. But I think that's probably beyond most of the end users for like a web server. That's going to be the kind of thing that's going to actually get incorporated into the patches that roll out to customers. So as with all things, as with all vulnerabilities, I mean, the standard advice is patch, patch. As soon as it's available, patch early, patch often, patch. So that would be, in a word, my recommendation. But beyond that, I would say, the reoccurring theme we see with this vulnerability or other vulnerabilities is the need for us to have a kind of a large asset inventory to understand exactly what systems are out there before that, so that then we can use that to understand kind of what systems might be vulnerable. Yeah, so does that answer your question?
It does, and I feel like this truly highlights a different challenge that a lot of maybe larger organizations and businesses are facing today, and that results in creating a more of a panic scenario whenever they hear about a 0-day or when they hear about this type of a CVE that gets released. We had the same type of issue with Log4j as an example. We saw the same type of thing with Struts CVEs in the past as an example. So you have these widely used technologies, let's call them in general, right? They could be software, they could be, functionality, they could be protocols, they could be open source libraries, etc. But you have all these technologies that are being used widely. And it seems to me like the bigger challenge in this particular scenario is that organizations really struggle to have an up-to-date asset inventory. And not only having an up-to-date asset inventory, but truly understanding what software components, what versions of packages, what type of bill of materials they have in those assets. So being able to have an up-to-date inventory, especially in a world today where we have, DevSecOps, CI/CD pipelines that allow you to release software on a few minutes at a time, or every hour, or every day, or every week, and you start seeing these ecosystems that are changing at a very rapid pace. So it's very hard a problem to have, especially if you don't have a strategic solution in place to systematically and automatically go and keep an up-to-date inventory of all your systems that you own and you have exposed to the internet. And then the struggle with the change is we've now gone into the cloud world, where it's not only rapidly changing, but your infrastructure may grow and shrink in a matter of hours. I like to think of the example of like Black Friday, right? When you have Black Friday deals, or when Apple releases a new device that there's a lot of hype about, people go and bombard those applications to try and get that deal. Yeah. And at that time, these organizations have built software and infrastructure in the cloud that can truly scale as the demand for traffic increases, and then scale down in a matter of hours. So having a proper view of that internet-facing perimeter is just so challenging to manage that you really have to have a proper attack surface management strategy to be able to understand where your assets are, and then also be able to understand what components you're using, what versions of the components are you using, are there known vulnerabilities in those components? Do you have mitigating controls against those components? Do you have DDoS protection? Do you have web application firewall? Do you have identity and access management? Do you have proper error handling and logging? It becomes more and more complex way quicker than people expected. So I find it really interesting and exciting that this is a challenge that we're trying to solve, I believe, as an industry. And based on everything you said, I feel like we should highlight some things around this specific CVE, and similar things happened with Log4j, where we actually have clients that leverage our attack surface management solution, and that allows them to manage their risk on their perimeter. But we were able to help those clients once they found out about this 0-day. They contacted us, and you and team did an amazing job of literally responding within hours and building and adding automation to our platform that allowed these customers now to actually have a proper inventory of where they have HTTP2 and where they need to be focusing their energy on from a mitigation and remediation perspective. I feel like that's an extremely unique and great example of a success story where NetSPI, being on the cutting edge of offensive security testing, we were able to help many organizations in a meaningful and impactful way address this particular challenge, where otherwise they would be in a panic situation where they don't really know what to do and how to approach the problem without a proper asset inventory. I want to go off script a little bit, Isaac. I would love to learn from you at least. As we built this automation into the platform, what was your approach, and how did you think about the problem? And you were able to solve it so quickly. I'm curious if there are specific things about this vulnerability that allowed you to actually build that automation quickly.
Yeah. So first, I want to correct you and say, and I know you didn't mean it this way, but it wasn't me. It was a team.
It was our team. It was our team. Yes.
My contribution
absolutely.
was actually I think the
have
minor
access
part.
to you right now. So I have access to you right now. So to me, you represent the team. So tell us about the
Sure.
team.
Sure. So I think the first thing is you just the kind of speed of response. So that's one of the things I'll say of our team is, it's really actually quite cool, like for somebody like me and in my role, to be part of a product where that on the drop of a hat we could put out a feature that is actually going to cause like a significant positive impact at scale. So so the first thing was, the head of our team, Jake Reynolds, sends a message to a few of us on Slack and says, "Hey, all hands on deck, we've got a thing." It's like, okay, so we start chatting on Slack, and at this point, I should point out and call out our ASM operations team, which is one of the kind of unique features of NetSPI's ASM platform, is we have a whole team of security professionals, consultants themselves, who are constantly kind of just working on ASM clients and working to kind of verify vulnerabilities, and to go out and look for things in those clients. So by this point, I think our ASM operations team was already off and running, and they were kind of manually exploring all of these things and trying to figure out like what the right approach might be to get to detection of these for all of our customers. So we came up with the first approach, which seemed kind of like the most comprehensive, if not the most precise, was to just detect everybody out there who's using HTTP2. It's a fairly simple thing to do. You just try and communicate with the servers and say, "Hey, do you speak HTTP2?" They say, "Yes, I do," and specifically, without downgrading you. So we went out and just added a feature, and it was as simple as a couple lines of code in one of the scanners that I've already written. And on the backend side, our software engineers went in and kind of handled the database pieces of that, and our front end guys went in and put in the UI to expose it to customers and added in the search functionality. And so within, I think, 45 minutes from start to finish, from that first message from Jake till the time it went live into production, 45 minutes, I think, is how long it took, which is super exciting and super fun to work on. And it's the kind of thing that I think, if I'm be so bold, is a differentiator for our ASM platform. Is just the flexibility we bring to the table is pretty amazing, in my humble opinion.
No, couldn't agree more. And I wanted to highlight that and give kudos to the team for being able to do this so quickly. I have one more question as we run up against time, so maybe Isaac will give you 1 minute to answer this one. But what I would like to understand from you is, I've heard people throw around that say, okay, well, just turn off HTTP2, right? Or downgrade from HTTP2, right? What is the true challenge of downgrading from, let's say, or turning off, let's say, HTTP2 and 3, and then going back down to, let's say, HTTP 1.1?
Sure. So I wanted to come back to complexity, and you gave me the perfect opportunity to do that. So I'll give kind of a high level response to that. But I think that the thing about complexity, and not just in computer systems, but just complexity generally, is that it's defined by its tendency to produce kind of unpredictable consequences or outputs from the system, from the complex system. And so I can't tell you what the problem associated with changing one component in a complex system might be, but it might be bad. So and I think this really underscores the importance of having somebody on your side who understands kind of all the potential implications of these sorts of things and can kind of help you navigate that landscape. It's also the importance of of patching, because if you patch, somebody else, fortunately for most of us, has already their products in a way that's not going to break things and is going to maintain kind of backwards compatibility. So so I'd say I can't say specifically what the issues associated with that might be, but I can give recommendations that people patch and that they trust security professionals and companies who know what they're doing.
Love it. Well, thank you, Isaac. And I want to thank our audience as well. If you want to connect with us about attack surface management or any type of offensive security testing, would love to chat with you. Connect with us at www.netspy.com/contact-us. But we have a few more minutes left. I want to see if there's any questions from the audience. I see there's a lot of engagement in the chat and a lot of great comments here, and finding this one here about finding balance between speed and flexibility in businesses and how to do it properly. Any thoughts on this one, Isaac?
Yeah, I mean, actually, the thing that this one that just popped up on our screen here, the shadow IT thing, that's one of the things that is honestly, as a security researcher, like it's in the attack surface management space, like that's one that kind of me and the whole team kind of are up at night thinking about is, how do you know if some engineer up some web server that's part of your organization, but not necessarily within your ASN or whatever. So no specific response other than to say I think that nails it perfectly. There's all these different kind of optimization points that are all themselves super important. And I mean, if anything, it makes for a really interesting problem space to work in.
Well, if there are other questions, we'd love to hear from you. So please feel free to reach out to us. Again, we're at www.netspy.com/contact us. And Isaac, all I have to say is thank you and the team for a rapid response on Rapid Reset. And I know our customers appreciate it. We're excited that our audience was able to hopefully get some more value and learn from us. And we look forward to chatting with you next time.
Thanks, Nabil.